Do you need glasses if you wear glasses?
Take them off.
I mean, you got light.
See a white ball, then you see little black specks in it?
Yeah.
They're better. Light blue doesn't have chocolate.
Okay, cool.
I do. Does my eyes burn up?
Can. Just a little bit.
It kind of looks like Jupiter. Who's leaving? I heard someone say that.
Yeah, you're seeing the clouds from.
Oh, it's the clouds. They're talking.
Can I borrow your tube? Put this in.
You know what? Maybe you should text Bailey while you're at it. Oh yeah, Martha.
I guess while we're doing this, we can go over.
Dude, I just saw Nick say something.
We can go over how we're able to look at the sun with a telescope. On the front of that telescope is a solar filter, which blocks out
Pay attention, okay?
Yes, sir.
99.9999% of the light. You got like maybe 1,000th of a percent of the light coming off the sun into the telescope. That's so that it doesn't fry your eye. There's actually an example on YouTube where a professor at a museum shows some students.
You still want to look? You can go ahead and be looking.
Shows some students the power of the sun by taking a telescope, putting a grape on the ground, and vaporizing it with a telescope.
But you do that right now?
No, I can't. No.
Aw. Wait, did it like completely poof away?
Yeah.
Like, so, wow.
It's caught on fire.
I do not want that to happen to my eye.
Hey,
Everybody want to look? The sun while it's still there?
Really?
Yeah.
Oh, this was a safe one, right?
Yeah.
Safe one? Yeah. All right. Oops.
Can you still see it?
Don't bump it.
now the reason this is safe is got, like I said, it's got a filter on the front of the telescope that blocks the light from getting into the telescope.
Is it working?
Do you see the white ball?
You gotta tilt your eye a little bit.
I have a question. I'm like, what happens if you put the lens in the
The
back?
big white ball with the black specks?
Because the telescope focuses the light on the filter,
Bump the table, guys.
it would get extremely hot and it'll either melt or crack. And then it'll let all that concentrated light in to your eye and then burn it.
You might have to check it again. Let me hold that.
Yeah, let's see.
She's got something in it.
No. Oh my God, staring in the sun.
Really?
No, this one won't break.
I'm going to put my filter in this.
Okay.
The heck?
Actually, if they make like these lens thingies that you can stare at the sun, no matter what. Are you okay?
Yeah.
That's interesting.
Okay. Now, what we have here is examples of 3 different types of telescopes, optical telescopes. We have, I'm going to start with this little one. This is what's known as a Newtonian reflector because it uses a mirror in the bottom of the scope to focus and reflect the light. The light comes in, bounces off this mirror, bounces off a secondary mirror up front, and then into the eyepiece. The advantage of this telescope is you can make a very powerful telescope very inexpensively because mirrors are cheap. They're also, it's just a tube. It's an inexpensive, easy to make telescope. Another example we have is this right here, which is a refractor, which has a lens in the front of it.
Wow, it's playing.
Now, this is just one I have to carry around for just this kind of, hey look, here's a telescope. What happens here is light comes in, this lens focuses it down to where your eyepiece would be, and this is star diagonal. The eyepiece would go in here. It's these telescopes are I got an eyepiece cover. These are the most common and some of the first types of telescopes built this way. The problem with this model telescope, to get a big, high-power telescope, lenses are hard to grind, thus they're expensive. So when you start getting past about 6 inches, a telescope like this starts getting really expensive. Whereas past 6 inches, you're still looking only hundreds of dollars, whereas this past 6 inches, you're getting in thousands, up to close to tens of thousands of dollars. The third type of telescope we have here is called the catadioptric. It is a hybrid. It has a lens in the front, then that focuses the light a little bit. The light comes in, bounces off a mirror in the back, goes back to the front, bounces off another mirror, and comes out the back of the scope where the eyepiece would go. The advantage of that is you can have an extremely high-powered telescope in a small package. This telescope right here has what's not a focal length, which is the light path. This is 700 millimeter light path. That one's 1500. Over twice the light path is this one, half the length, because of the fact that they bounce the light back and forth. This also allows for high magnification. That telescope with a 10 millimeter eyepiece is 70 power. This would be 150 power. The advantage of that scope is that you can get high magnification. They're inexpensive to make because they're hybrid, and they offer good views, better than the Newtonian, and for the money, better than the refractor. Now, of course,
You said that will turn.
now all the mounts you see here are of the type that's called alt-azimuth. What that means is that to track, they have to move in altitude and azimuth, which would be over and up to track objects in the sky. That's not the most efficient form of tracking objects in the sky, but it's one of the simplest. There's also a type that's called equatorial, that you would mount the pivot point and align it with Polaris, where Polaris be over here now, I believe. And that way the telescope only has to move in one direction constantly through the night. You don't have to move up, left and right, up and down, left and right, just left to right, once you find your object. That means that the object stays more steady. And unlike these telescopes, if you view for a long time, as the object goes across the sky, it tends to look like it's rotating over on itself. A equatorial mount telescope, because the way it rotates the scope through the sky, gets rid of that problem. They are harder to set up and use, but like I said, it's better viewing. It's just a better mount. Basic parts of a telescope, of course, the lens, eyepieces, which we've already covered. You have some sort of star finder, which allows you to, when you're looking at the stars up in the sky, this particular type has a bullseye type system in it, where you center it in there, and it should be, if it's aligned properly, you'll be able to find it in the eyepiece. That's important because if you want to look at perspective, that telescope right there with the right size eyepiece is like trying to find something looking through a straw. I mean, that's how much sky you have to look through. So you use the Starfinder, Telradness is the name brand of that one, to help you get in the general vicinity, and then you look for your object. You've got, you got the 3 different kinds of focusers here. The focus on this scope's here. Of course, the focuser's here on this one. And then on this scope, the focuser's on the very back of the telescope. Of course, what that does is that allows you to bring the eyepiece into a focus with the telescope, so that way you can use multiple different eyepieces to get different magnifications. The way to calculate magnification on any telescope, it's actually really simple. It is every eyepiece has a focal length noted on it. Like I mentioned, a 10 millimeter. That means